x plus 3, I'm going to have x plus 3 quantity squared, because this x is being squared, plus 2 times x plus 3. What do I need to do with this part?
Foil.
Foil.
You get x squared.
Hang on.
Out of the gate.
You guys are working faster than me. X squared plus 3x.
Plus 3x plus 9.
So I get x squared plus 6x plus 9.
And
Everybody
then
good with that? What do I do with this 2 here?
you distribute it in.
Okay,
So
so I have
2x
plus
plus
2x plus 6. And then I need to combine like terms, so I have x squared. Those two can go together.
8x
So 8x
plus 15.
plus 15. And then you're done. How'd you guys do with that?
Good.
Easy? Easy, easy? Okay, good, because we're going on today to 2.3. So go ahead and grab your notes for 2.3. Analyzing graphs. I'm going to do this in 2 different days. And today's, it's pretty easy, I think. There's only one part that's a little tricky. Okay, we ready? Okay, I'm going to attempt to draw this graph here. I'm sure I'll do a great job. Let's see. There's a dot here.
This looks great.
Thank you.
You're welcome.
So far, so good. Okay. Okay, here is my graph. First thing we're going to talk about when we're analyzing graphs is domain and range. And we touch on domain and range a little bit with in Algebra 2. But does anybody remember what the domain represents? It's either x or y.
X.
X. Domain represents all of the x values, which would be left to right here. And range then represents all of the y values, which is how low the graph goes to how high the graph goes. So in this graph, when you're talking domain, you're looking from way out here, and you're just going to scan this way, and you're going to see that the first x value that you have a graph is what? On my graph. -1, so that's the first value, and that's included because it's a closed dot. And what is the last x value that you see as you scan from left to right?
5.
+5. Is +5 included in my graph?
No.
It's an open dot, which means we don't include it. It means up to 5. So in that case, I would have 5. And how do I show that I'm not including it? Parenthesis. Okay? So my domain goes, you start over here and look this direction. First place I see is this -1. The last place I see is the 5 that's not included.
So you do the first and the last, like, is the farthest, so you don't do like the middle ones?
No, I'm just showing you the range. The domain, I hate to say the word range because I'm showing you the interval from -1 up to 5. There's a graph. Okay. Now there's times you have to talk about the middle ones if it like splits, and if this would have been an open dot here, then you would have had to go up to that dot and then from that dot to that dot. But when it's just constant, you don't have to talk about the middle part. So if domain started at -infinity on the x, where do you think range starts?
On the Y.
On the y. So you're looking down here and you're looking up. What's the first y value you see of the graph as you scan up? -3. Is -3 included?
Yes.
Yes. And what's the highest y value? 3. This dot right here. And that is also included.
Doesn't matter which one you put first.
You want to put the smallest one first. So we start with the negative. Okay? So let's look at another graph that won't be as specific. So I'm going to do a parabola that shifted down 1. and has arrows that go on forever. So if I'm talking my x values here, this parabola is going out here forever. So if I'm out here at negative infinity, I still have this graph because these arrows mean that they're going on forever. So this one would go from negative infinity up to what? Positive infinity. You can also say all real numbers for this one. But the x values are going forever. You don't have a starting and a stopping point. The y values, though, do have a starting point. What's the starting point for the y value? -1, and that's included. And then what's the ending value for the range? Infinity. Okay, so that's a little bit of the domain and range that you're going to have to look at. For some reason, domain and range is sometimes hard to wrap our head around, but I think we can do it. I know we
Infinities
can.
are hard to draw.
Hard to draw.
Yeah.
You can do it, Billy. I know you can. I know you can. Oh, the infinities are hard to draw?
Yeah.
What did you think he was talking about?
I thought he said these are hard to draw, like the graphs. I think you can do it. It's like a smiley face without the eyeballs.
With 8, but I don't even know. It's weird.
I know, it's tough, you guys. It's tough doing that.
Yeah.
I can't even imagine. Okay. Oh, we've got one more thing we have to do.
There's something missing.
Huh?
Nothing.
Missing for what?
Nothing.
Okay. Oh my gosh. I'm going to have you guys remind me that there's one we need to do together, but it's in the book. So I'm going to finish your notes, and then we'll start with that one together. Okay? Just remind me. Okay. Did we talk? I think we did. Did we talk on Friday about vertical line test?
Yes.
If it's a function or not? Okay, so you know how to do that. So the last thing I'm going to give you notes on until I give you the example out of the book is to find a zero of a function. A zero is basically solving for x when y is 0. So it's finding the places that it's touching the x-axis. So if I give you something like this, f of x is equal to 3x squared plus x minus 10. So we're finding x when y equals 0. What's the y up here? F of x. So we're going to set this whole thing equal to 0, and we've done this before. What do we need to do to solve for x here? Starts with f and rhymes with actor. Factor. Or a quadratic formula, but this one does factor. So we need to factor this. So the two numbers I'm looking for are -30 and 1. Can we do the shortcut with this problem?
No.
No, we can't, because the a term is not 1. So my two numbers that multiply to give me 30 but add to give me 1 would be 6 and -5. So I have 3x squared plus 6x minus 5x minus 10. You guys with me? I'm kind of going fast because I'm assuming that we all know how to do this. Take a 3x out, so I get x plus 2. Take a -5 out, so I get x plus 2. So my factors are 3x minus 5 and x plus 2. Now what do I do with each factor to solve for x? This was on our last test. Set them equal to 0. So I have 3x minus 5 equals 0, and x plus 2 equals 0. So add 5, 3x equals 5, x equals 5 over 3. Subtract 2, x equals -2. So these are the zeros of the graph. So if I was to graph this function, it would touch the x-axis at 5 over 3 and -2. That's the definition of a zero. Easy enough? Okay. Okay, I've got 2 more of these, and then we'll do the one in the book together. Let's say I give you something like this. G of x equals the square root of 10 minus x squared. I want to find the 0. So what am I going to make 0?
The G of x.
G of x, because our y is 0. We're solving for x. How do I get rid of a square root?
Cube.
cube it or square it.
Square it. So if I square this side, what do I have to do with the other side?
Square 0.
Okay, and 0 squared is just,
0.
that's lovely. So I get 0 equals 10 minus x squared. Now I'm just solve for x, because I don't have two x's here, so I don't have to factor. I can just add this x squared over. So I get x squared equals 10, and how do I undo a squared now?
Cube, let me square it.
Square root. Oh my gosh, cube. So I don't have a perfect square for 10, so I'm just going to say plus or minus the square root of 10. And that's my answer.
Wow.
Wow.
Wowzers.
Okay, one more. It's as easy. But now we'll call this one h of x is equal to 2x minus 3 over x plus 5. Okay, if I want to find the 0, what am I going to make 0? H of x, our y value. So I have 2x minus 3 over x plus 5.
You do the reciprocal?
You don't do the reciprocal, but we're going to take all of this and cross multiply it up. And what's going to happen when I take x plus 5 and multiply it by 0? It's just going to be 0. That's lovely. So I just am left with 0 equals 2x minus 3.
But I thought you couldn't have a 0 on the bottom.
We don't. We multiplied it up here.
Oh.
We've got nothing on the bottom. So I've got 3 equals 2x, divide by 2, divide by 2. X is equal to 3 over 2. Easy enough? Okay, you guys grab a book and open up to page 207 for our last example. This Sarah Norman? No. Thanks. Bye.
What page?
207. And we're going to do number 5 together. Okay, I can't cast this up here, and I don't want to even try to draw it. So we're just going to try to talk through it.
We're doing number 5.
Yeah. I guess I'll try. Oh. I think it's going to be better if we just talk through it. Okay. What did we say? So number 5, part A, is f of negative 5. Okay? I'm sorry, that's not negative 5. It's a negative 2. It's number 5. Oh, dear Lord. Okay. So what is this value inside here? Is that an x or a y?
X.
That's our x. That's our input. So I want to look on the graph when x equals negative 2, what is my output or what is my y value? So you're looking at that graph right below, and you're going to go to negative 2, negative 1, negative 2. What is the y value of the graph at when x is negative 2?
Negative 2. Wait, yeah, negative 2.
No?
Did I get that wrong?
Wait, 0?
0. Negative 2 is the x value, but it's
You can-
crossing
yeah.
the the
You can't look down and see the dot. You have to.
well, we're looking at negative 2. It's on the x-axis, which is 0. So in this case, our y is 0. So f of negative 2 is equal to 0. That's our output. Let's try another one. Let's do f of 1, because that one's kind of easy to see. So our x value is 1. So we put our finger on 1, and we go find the graph, because it's not right on the line there. And what would the output be when x is 1? Not negative 2.
Wait, what one?
Say it loud. Not negative 3.
Negative 2.
No. Let me just, no?
2.5.
Okay, unless I'm looking at it different than you guys. okay, maybe I am looking at it different, because now that I hold it up and I can actually see it, I would go negative 1.5, or negative 2 would be okay, but negative 1.5 probably is, oh, negative 2,
What are you looking at?
the graph. We're looking at the graph.
The 5?
Yep, for when x is 1. Okay, now let's look at C, which is f of f of 1/2. So find 1/2 on the graph. I'm gonna hold this up so I can actually see it. 1/2 on the graph. What is the y value? 0, because it's crossing right at 1/2. So this would be 0. And then the last one up here that we haven't done is what, negative 1? So f of negative 1. So our x value is negative 1, and our y value is negative 1? Negative 1?
I'd say that's right in there.
Okay, so we'd say that is negative 1. Okay, so the point of these are you look at the x value, find the graph to see what the y value is.
So whatever it's giving you for the F is gonna be the X.
The input is inside the
And
parentheses.
the output is the Y.
And the output is wherever the graph is on the y value. Yeah. Okay? Okay, here's what you're going to do today. We have lots of time. So I just did number 5. We just did number 5 together. We're going to do page 207, 1 through 24. Tomorrow we're going to add on to this and go over all of it in class, if we get it all done. We've got 2 more examples tomorrow, 2 more things. The min and max and the increase and decrease. So what I'm saying is if you get done and you have 3 problems left or 4 problems left, you'll probably have time to get it done in class tomorrow. But if you have 10 problems left, I would probably take this home.